Uncle, please, how do you solve standard form with that nonsense jam called calculator? Okay, don't worry, we'll see an example on that. Uncle, please help me announce. I'm looking for biology past question, pre 50. Please, sir, help me and announce. My name is Peter Zalachia. Is it a nickname or what? I don't understand. The person I gave it to is a girl, but I cannot remember the face. Thank you very much. Okay? Why did you give a girl your past question? Eh? Please, if you are with a boy's biology past question, please bring it to me. Bring it to me so that I will find the boy myself. Okay, sir, can you please teach how to multiply big numbers like this without the help of a calculator? See, you cannot know how to multiply big numbers. You must use that calculator. You must use it. Okay? Now, but listen, look at what I can do. The problem you will have with that calculator is maybe imputing standard form, which you cannot. So look at what you can do. Like this one says 1.2 times 10 power minus 5 times 400. Listen. Look at what you can do. Of course, you can press this on calculator, but you cannot press this. So what you will do is this. Instead of trying to press all these things, press 1.2 times, you can say times 400, okay? 1.2 times 400 on the calculator. Forget about this guy. Don't press it. Don't press any standard forms inside there. Just press this and this. And whatever it gives you, oh yeah, help me out. What will it give you? 4.8, Abi? So I have, Abi, is it, 4800. Oh yeah, Abi, just 480. Okay, just 480, right? Now, it gives you 480, then you say times 10 power 5, just like that. Okay? Then, you need to convert this guy into standard form. Okay? You can move this decimal 1, 2. This is 4.8 times 10 power 2. Then times 10 power 5. So, in this is 2 plus 5 is what? 7. So, the answer is 4.8 times 10 power 7. So, you only use the calculator to multiply numbers. But whenever you have index form, you use laws of indices and do your indices. Okay? So, let's say you have something like 3.2 times 10 power minus 7 times 1.3 times 10 power 5, maybe all over 2.5 times 10 power, let's say 10, as an example. If you want to do it with that calculator, you don't need to put any of these indexes. No, don't put it. In your calculator or in that jam calculator, just press 3.2 times 1.3 times divided by 2.5. Are you with me? So on that jam calculator, you click it, you open it, you press 3.2 times 1.3 divided by 2.5. You open on your way. Let's assume it gives us, let me just say it gives me 2 points. Or let's say 1.8, an assumption. I'm a calculator to give you something else. But let's assume it gives us this. Then I will now say times 10 raised to power. I will combine this and this. Minus 7 plus 5 is what? Minus 2. Then this 10 will come up, or below minus 10. So it will be 1.8 times 10 power minus 12. Do you get it now? We have not started class. All these questions is okay. At least it means that you saw questions that maybe were confusing to you and you remember. Sir, please, can you help me solve? Solve for what are they looking for? What are they looking for? So, please, the person that drew the diagram, just... Oh. Okay. If the mirror is turned as indicated by the arrow through 40 degrees, what angle will the reflected ray make with the AY? Please help me. Okay? I don't want to go back on that. I don't want to go back on this. But please, the person that brought that question, you can meet me later so that we don't go back and waste our time. Mr. Prime, thank you so much. What you taught us mostly came out in the exam, and I was very happy. Thank you so much, sir. We love you. From the girl that brought water for you the other day. I cannot remember who. Please, I cannot remember. The girl that brought water for me the other day. Who, please? I don't know. I don't know. Okay? I might remember if I see the person. I might remember, but I don't know. I don't remember. Okay, so where did we stop, please? Please, it's okay, please. It's okay. Sir, please, it is not a boy's past question. I am a girl. The name is Peter. Just my surname. Please, I hope I can find it. Okay, so the person is actually a girl, but her surname is Peter, okay? So please, if a girl gave you a biology past question, but you don't recognize the girl, or you don't, but you want to return it, please come. Just bring it to me, okay? Yes. This is not the time for you to take somebody's past question. Don't take somebody's past question. In fact, there. So don't take somebody's past question, please, because you are causing them to cry. So look for that person. Look for that person, or you bring it to me. Okay. Now, yesterday, or was it yesterday? Sorry, day before yesterday. Day before yesterday, we stopped at refraction through triangular prism. Yeah? And you have taken that diagram. Oh yeah, I want you to write down. The diagram shows a ray of light incidents. The diagram shows a ray of light incidents on a triangular glass prism, on an equilateral 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 triangular glass what? Prism. XYZ. 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 Have you done that? XYZ. Footstop. Footstop. Please, I need a clearer marker, please. The TV at the back is not showing. The marker is kind of faint on the TV. Okay? Please review the markers for me very well. Cut it very sharp. Cut it very sharp. Oh yeah, let's continue. Let's continue. I is the angle of incidence. I is the angle of incidence. I is the angle of incidence. And E is the angle of emergence. And E is the angle of emergence. And E is the angle of emergence. And E is the angle of what? Emergence. And E is the angle of emergence. Full stop. Full stop. Usually, comma, the angle of incidence is not equal to the angle of emergence. Usually, comma, the angle of incidence is not equal to the angle of emergence. Usually, comma, the angle of incidence is not equal to usually, comma, the angle of incidence is not equal to the angle of what? Emergence. Except at minimum deviation. 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 Except at minimum gain now deviation. Full stop. Full stop. Full stop. The deviation D, the deviation D is given as D equals I plus E minus A on the board. The deviation D is given as I plus E minus A, where D is the deviation. Wait first, we say please, we found some keys here in case you are looking for your key. Check very well. If you are looking for your key, you can come and get it here. Okay. Have you written that? Okay, where D is the deviation and A is the refracting angle of the prism. And A is the refracting angle of the prism. And A is the refracting angle of the prism. And A is the refracting angle of the prism. And A is the refracting angle of the prism. Usually, A equals 60 degrees. 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 60 degrees. Have you done that? Usually, A equals 60 degrees. Now, let's continue. At minimum deviation, I equals E. I equals E. Therefore, N equals sine dm plus A all over 2 divided by sine A over 2. Like that. This is the formula. Write it down. We can say that where dm is minimum deviation. 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 Now, right. When a graph of deviation when a graph of deviation is plotted against when a graph of deviation is plotted against the angle of emergence, if a graph of deviation is plotted against the angle of emergence, the figure is obtained. The figure is obtained. Then you sketch this graph we are about to sketch now. So we have D on the vertical axis, and this D is the deviation in degrees. And then we have the E on the horizontal, which is also in degrees. This is what we will obtain. Now sketch that graph. Sketch that graph. Are we ready now? Okay. Oh yeah, look up and let us explain what we've said so far. Class, we are talking about the refraction through a triangular prism. Please pay attention because I'm going through it just once. Now, if you look at this, we have an equilateral triangular prism. When we say equilateral triangular prism, what does it mean? Equilateral triangle means that all the sides are what? Equal. All the sides are equal. Now, when we have a ray of light entering the prism from this face, refraction will occur and it will emerge on the other side. So we said that I is the angle of incidence and the E is the angle of what? E is the angle of what? Good. For a rectangular glass prism, we were talking about angle of incidence and angle of refraction. But for a triangular prism, the most important things are the angle of incidence and the angle of emergence. And of course, D, what did we say D represented? Deviation, angle of deviation. Now, we now said that the angle of deviation is related to the incidence by the formula D is equal to I plus what? I plus E minus what? A. So if we wanted to find deviation D, look at the formula. That deviation is equal to I plus E minus A. So if we wanted to find a deviation, deviation is given by this formula. Now, what does deviation really mean? Deviation is the angle between the incident ray and the emergent ray. The angle between them. That is what we call deviation. And take note of the location of that deviation. Look at where deviation is located, because we are going to see a jump question later that was asking us for the location where deviation was found. So take note of where it is located. Now, we now said, class, when we talked about a rectangular prism, of course, we were only referring to angle of incidence and angle of refraction. But here, we are referring to angle of emergence. Now, we said that angle of incidence is usually not equal to the angle of emergence, except at minimum deviation. Except at what, class? So in exam, I gotta say, at minimum deviation, what will happen? You will tell them that at minimum deviation, the angle of incidence is equal to the angle of emergence. What did I say? At minimum deviation, what is happening? Auntie you. This auntie on white. Yes. What did we say? You did not hear me. Because you were not paying attention. What were you copying again? The physics. So where did your attention now go? Chai. No, Allah, let's continue. I'll not come and kill myself. I'm still too young, please. I cannot die now. Now, at minimum deviation again, pay attention to this formula. This formula is very, very important. In fact, whenever they mention a triangular prism, this is the formula you make use of to find the refractive index. Remember, N here is refractive index. Up here? Eh? So whenever they mention a triangular prism, this is the formula we use to determine the refractive index. What does dm represent here? Minimum deviation. dm is the what? What did we say A represented before? Refracting angle. A is the refracting angle. And you should know it that A is always 60. A is always JAMB will not give it to you. They will not give it to you. A is always equal to 60 because it is an equilateral triangle. So all the angle is 60, 60, 60. So you should know that A is always 60 because they will not give it to you. So this formula is used for calculating refractive index for a triangular prism. For a Gene class. For a Gene class. Did I say rectangular prism? Did I say rectangular prism? What did I say? Triangular prism. As simple as that. Now, if we plot a graph of deviation on the vertical axis against the emergence on the horizontal axis, this is the kind of graph we will have. It is not a straight line graph. This is how the graph will look like. Now, from this graph, JAMB will ask you two questions. First question they might ask you is, from the graph, what is the minimum deviation? And I said that if you want to find the minimum deviation from the graph, all you need to do is go to the lowest point of that graph and trace it to the vertical axis. Is this the vertical axis now? You trace it to the vertical axis. Any number that is corresponding to that is your minimum deviation. Is your Gene class? Another question that JAMB can ask you from here is, they will ask you, what is the angle of incidence that will produce the minimum deviation? Or what angle of incidence or emergence will produce the angle of minimum deviation? And for you to get that, instead of going to the vertical axis, you come down to the horizontal axis. From hereby again, you come down. Any number that is here is the angle of incidence. Is the angle of Gene that will produce that angle of minimum deviation. I'm going to show you an illustration now. But before that, sir, please, are we still writing exam today? Which exam, please? We're writing any exam. Sir, there is a boy disturbing me at my back. Please, I think the TV at the back is off. Back TV. Is this still off? The one at the back? Is it on now? Okay. That boy disturbing you, be careful. Now, oh yeah, let's continue, please. Can I get a prep 50? Anybody? Can I get prep 50 from somebody? Okay, thank you. Let me collect this one. Now, we are going to take a question to illustrate this thing I have said. Because, you know, for some of you, the only way you learn is by when you see questions. That is how you learn. JAMB 2005, number 39. Do we have birthday mates here? Yes. And when that was 2005? Yes. Huh. Okay. 2005 to 9 is how many years? 19. Hey. 2005, number 39. They drew a diagram like this. Like this. And they said, okay, let me write down the numbers first. If you are using Prep 50, it is page 85, number 36. I'm seeing 14. I'm seeing 16. I'm seeing 18. I'm seeing 20. I'm seeing 22. I'm seeing 15 here. I'm seeing 20. I'm seeing 25. I'm seeing 30. I'm seeing 35. And they said that here, here is E in degrees. And here is D in degrees. Oh yeah, class. Look at the diagram. This is the diagram from that jam pass question. From that jam pass question. Is there a day I will enter this class and I will say everybody, oh yeah, open 2005 number 39. And everybody will open it. Will that day ever come? If that day ever happen, it means that Jesus is already coming. Because it's almost impossible. Past question. Where your past question day? Eh? Oh yeah, look at the question. They said, the figure below. Look at that figure. Anyone below or above? Anyone? The figure below shows a plot of angles of deviation through a glass prism when light is incident at 0 degrees on the prism. They now said, the incident angle that produces the minimum deviation is, the incident angle that produces the minimum deviation is, the incident angle that produces the minimum deviation is, so meaning that in a diagram, what angle of incidence will produce the angle of minimum deviation? Until you, go you. In that diagram, what is the angle of incidence that will produce the angle of minimum deviation? Do you want to show me how? Chest it down. You chest it down. Yeah? So if you chest it down, it's 5. You're not even sure. You're not even sure. Brother, oh yeah. What's the answer? Do you want to show us how? So from where? How did you know it's 25? Why is it not 30? Why is it not 35? Where is the angle of deviation? Auntie, oh yeah, look at it and tell me. Yes. Where is the answer? Why is it 25? Eh? Why is it 25? So you are saying 25 because people are saying 25. So why is it 25? Yes. Look at it and tell me the answer. Why is it 25? Like how? I don't get. Yes, what is the answer? Look at it and tell us. Why is it 25? So if there was another question, you will be able to identify it. Yes. Yes, you. What is the answer? What is the angle of the minimum deviation there? Eh? You don't know. If you are late, you come tomorrow, you go and stay in front. Do you hear me? Oh yeah, give me that phone. Pass it, pass it, pass it. So why are you on WhatsApp? Give it to you. Oh yeah, what is the answer? Why is it 25? Because they answered 25. Auntie, can you answer? Eh? Why? Why is it not 30? Why is it not 35? Why is it not 14? Why is it not 10? Why is it not 18? Why is it not 20? Why is it not 22? Eh? You said? Why the noise? I am not saying, I'm not asking you to make noise there. That's auntie with the golden hair. I can see you from here. If I come and meet you there, I will make sure I change the color. Uh-huh. You don't know why. Where's your question? You're not waiting. He's at home, preparing for jam. Eh? You should be coming with it every day. Even if they don't use it in class, you use it on your own during break. You cannot have past question and leave it in the house. What is happening here? Keyo? Keyo? Let me just catch anybody now. Oh yeah, you go and stand in front of that place and I watch again at TV. Where's your past question? Eh? You're not waiting. Do you even have? Do you have? What is the answer? Do you know how? So if I say you should come and explain, you explain it. Eh? No, if I ask you to explain it to me, can you explain it? Really? Really? Nyamia. Gbabia. Yeah. In a head, do we look at the innocence? In a head, do we look at the innocence? Do you want to say something? What is the answer? What is the answer? Eh? The question that they asked. Why? If you join it. Oh yeah, collect marker. Collect, oh yeah. Go and explain it. Go and explain why the answer is like that. Jewebene, Ebobuna, you are now, the question is now so simple that you have neglected the question and started pressing phone. Oh yeah, go and explain to the class how it is like that. Jebe? Take mic, in fact. I hope the TVs are working. And the TV is working. Don't worry, they are coming. They will come on. So that she will be showing on the TV. She has never been on TV before. Yes, oh yeah, auntie, oh yeah, move. Go. What is happening there? Is somebody giving you expo? Who is that person? Oh yeah, the person, join her. Who are you asking? You are not asking any Oyajobe. You are different. Climb the stage. Is she showing on the TV? Auntie, move like this. Move to the board. Yes, we can see you on the TV now. Oya, answer the question. You are next. Yes. Okay. Oya, answer the question. Let me read the question to her again. Is anybody making noise? They said the figure you are seeing on the board shows a plot of angles of deviation through a glass prism when light is incident at 0 degrees to the prism. The incident angle that produces the minimum deviation is... Oh yeah, get the answer. If I had my phone here for video you, post it for TikTok. Jamb is not your mate. Hashtag Jamb is not your mate. Oh yeah. Get the answer. How is it? Show me how it's 25. I'm watching you people. I'm watching you people. How is the answer 25? You know, some of you you will act stupid. You'll be acting stupidly because you feel standing here is very easy. Don't disturb. Pay attention. You think it is easy. Auntie, we will stay here. Eh? Show me. Because the angle is 60. Which angle is 60? Show me how it's 25. Leave me alone. So cousins, I was just talking to myself. Show me how it is 25. Show me how it is 25. And when you replace Yaba. Oh yeah. It's Onya now. That person that you are looking at. Show me why it is 25. Oh yeah. See, what we save you now is, oh yeah, show me what is the angle of minimum deviation there. In that diagram now, go show me a minimum deviation, no day. Eh? You see, I don't want to hear. Better respect yourselves. Respect yourself because I am already vexing. Go show me now. Go show me. Show me how. Show me how it is 18. Show me. Do it. Open the mark and show me. So eba anketa bụ 18. You don't know how to explain it, but it's 18. Are you looking at me, Jesus? Hey, Jesus. Hey, I talk about them because. Hey. you want to tell us something? Give my marker. Go and sit down. I've been no one sit down again. Now, what is the answer to the question, class? Is it 25? Because at this point, this is the minimum point of the curve, right? So from here, if I trace down like this, the angle of incidence that gives me the minimum deviation is 25. What if the question was, what is the angle of minimum deviation? So from here, I trace it like this. Up here, Obulu 18. Now, last year, JAMB, look at the question they asked. They brought a diagram like this, and then instead of asking us to find the minimum deviation or to find the angle of incidence that gave minimum deviation, they said from the diagram, we should find the refractive index of that triangular prism. So from the diagram, we should find the refractive index. Now, this is the formula you will use now for that. Do you know the value of dm from the diagram? What is the value of dm? 18. Okay? Or whatever that diagram is. It's in here. In this case, it is 18. It's in here 18. You know the value of A. A is always what? 60. So you will say 18 plus 60, and then you continue solving. Do we get that now? Good. Another question. This is JAMB 1997, number 38. JAMB 1997, number 38. JAMB 1997, number 38. Okay, this was the diagram they brought there. They now said, in the diagram below, which of the angles, theta 1, theta 2, theta 3, and theta 4, is the angle of deviation of the ray of light through the glass prism? So which of those angles there shows the angle of deviation? Is it theta 3? Is it theta 3? Is it theta 3? Good. So that is that. Theta 3. Okay, another one. Yes? Who is sorry me? Is it you? What happened? They what? Theta 3. They are just asking for deviation now. So from the diagram we drew before, from the diagram we drew like this, that initial diagram we drew, this was going like this. Okay, emergence was going like this. So when two of them intercept, that was your D now. So when you compare, D and theta 3 are matching. Okay, so both of them are matching. That is what they are basically asking you. Okay, another question. 2002, number 35. 2002, number 35. 2002, number 35. Any birthday mate here? 2002. Number 35. Ewoyamo na 2002 eba. Why are you not married? You want to do what? You want to test what? Single life. Okay. Are you not done testing? Okay, look at the diagram. Look at that diagram there. That is the diagram. They now said, calculate the refractive index of the material for the glass prism in the diagram above. Calculate the angle, sorry, not angle. Calculate the refractive index for the material of the glass prism. Calculate the refractive index. Class, in that diagram, do you know your angle of minimum deviation? What is deviation there? 30. Can you find the refractive index? Or you get the answer. And the answers are in short form. I want to see everybody solving. I want to see everybody solving. No, no, for my dear. I want to see everybody solving. Try to get an answer. Shebi, I have given you a list of trigonometric ratios. That is all those special angles. I get so use it as an assistant to yourself. Get an answer. You must get something. In fact, let me write out the option. If I point at you, you tell me your option. This should be root 2 over 2. And this should be I'm seeing 4 over 2 here, but I don't know where it is. Okay? But 4 over 3. Okay. So if I point at you, you tell me your option. Only one get melo get better. The answer. You will come and defend it on the board. What do you get? Is the answer A? Yes. Good. If you're not getting A, I don't know where you're coming from. Okay? So answer is A. You will use that our formula and the answer will just come out. So you guys are simple, right? Okay. So I say N is equal to sine. What is the deviation here, class? Deviation is 30. So 30 plus 60 over 2 divided by sine 60 over 2. Are we here? Good. This becomes N equals sine. This plus this, 90. 90 over 2. 45. All over sine 30. Are we here? Somebody that don't want to point now went to say 5 here. Is 5 into 30 is 6. Into here is 9. 3 here, 2. 3 here, 3. Answer is 3 over 2. Osimuno B. Boy alpha. Boy alpha. Okay? So, what is the value of sine 45 in short form? Aqua root 2 over 2. Divided by sine 30 beginning 1 over 2. So we have root 2 over 2 times 2 over 1. Aquia? So we have root 2 as our answer, right? If you got it on your own without any mago, clap for yourself. If you are clapping for yourself and you did mago, it's okay. Don't worry, I will catch you now. Another one. Ready? Ready? Are we ready now? Another question. 2004, number 5. Jam 2004, number 5. Jam 2004, number 5. Jam 2004, number 5. They said, Calculate the angle of minimum deviation. Calculate the angle of minimum deviation for a ray which is refracted through an equilateral triangular prism of refractive index 1.4. Bottom line is you are looking for the minimum deviation. Refractive index is 1.4. Solve. Did I say you should not get past question? Refractive index is 1.4. They said find the minimum deviation. That is, you are looking for DM. This is when we will know who is machine and who is not. 1.4, no. Refractive index 1.4. As to get your minimum deviation. This is when we will now know the machines. Ndi mama so fuma. We will catch them now. What did you get? Abuda is Yoku. That cannot be that is math magic. It's math magic. Oh yeah, can we solve together? Yes. Can we solve together? Yes. I know you've given up. I know you've given up. I know you've given up. Oh yeah, look at how we can solve that. Now, we are still going to use that same formula. NA is equal to sine dm plus 60 over 2 all over sine A over 2. Are we here? What is NA now? 1.4 equals sine dm, we don't know, plus 60 over 2. That person that said 2 year 1, 2 year 30, waka. Over sine 30. Are we here now? Over sine 30, because 60 over 2 is 30. Good. Now, we can cross what now? So we have 1.4 times. Class, what is the value of sine 30? So 0.5 equals sine dm plus 60 over 2. Now, 1.4 times 0.5 will give me 0.7 equals sine dm plus 60 over 2. Are we here? Then I get the sine inverse of 0.7. So sine inverse of 0.7 is equal to dm plus 60 over 2. So what is the sine inverse of this? Just press it. I will show you how to get the answer later without that. Press it first. 44 point what? 44.42. 43, no problem. Equal to dm plus 60 over 2. Are we here? You cross multiply. This guy multiplied by 2 is 88.86 equals dm plus 60. Make dm the subject. 60 will come over. 88.86 minus 60 equals dm. Are we here? So what is my dm now? 28 point what? 86 or approximately 20 guinea 9. Did anybody get it? Yes. Okay. Oh yeah, listen up now. Listen up. You know that in JAMB, look at the options. Option A said 29. Option B said what? 60. Option C said what? 99. And option D is what? 90. Now these are the options. In JAMB, they give you the question, they don't care if there's a scientific calculator or not. Obviously, they know that there's no scientific calculator, but they don't care. So how can you get the answer? Class, all you just need to do is ask yourself, when you look at this, 0.7, 0.7 is close to 0.7071. Okay? 0.7 is close to 0.071. And 0.7071 is the sine of 45. Are you with me now? Is the sine of 45. If you are sine 45, this is it. This is what it will give you. Now, you can now tell them that, you can now tell yourself that this guy is approximately 45. So, since this number is close to this number, then this guy will be close to 45. Iwe 45 is equal to dm plus 60 over 2. Cross multiply. 45 times 2 is what? 90. Then 90 minus 60 will give you what? 30. 30 is close to 29. You pick it as your answer. 30 is close to 29. And of course, if you get 30, you know that in the option there will be 30, but you know 30 will not be your answer. Why will you know that 30 will not be your answer? Because you know that you approximated. Are you with me? Because if it was 30, then that means Okushibu 0.7071. But you approximated this to this. That was why it is 30. So you should look for an answer that is less than 30. That is how you can get it. Okay? Apart from that, there is no other way. Unless you want to now hug a transformer and die. Then when you die, you become a spirit and you now know it all. Yes. You know, as a spirit, you know everything, right? Do you want to try it? You want to do practical? Okay? Can somebody die and come and tell us? You know, some persons used to die every day. When everybody is sleeping, they will die. And go and do meeting and come back. Okay. Now, write down for me. Write down for me. Areas refraction is applied or is observed in. Just write it like that. Areas refraction can be observed in. 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 Going past question. Okay. We'll use it later, but I may go the other stuff first. Areas that refraction can be observed in. Have you done that now? Oh yeah, pay attention, listen and listen carefully. Class, there are so many areas that refraction can be observed in. We are going to discuss most of them, and then, in fact, let me just list them down for you so that we'll now be taking them one after the other. For example, number 1, we are going to see the bending of objects in water or a liquid. We look at that. We are going to study about the fish-eye view. And we are also going to talk about the real and apparent depth. Real and apparent. Please, I don't know if I got the spelling of apparent there. Did I get it? Okay, there's no T here, just T, right? Okay. Number 4, we're going to talk about total internal reflection. Total internal reflection. Okay? So, these are some of the areas we are going to talk about. Now, class, the last two, we are going to maybe talk about that in the next class, but I want us to maybe quickly discuss about this. Okay? Let me just quickly tell you about these two, because you might see questions like, that an object appears bent when placed in water, why, and so on. So we are going to study that and know what is going to happen. Now, class, Gente. So we are talking about some of the areas we can observe refraction. Now, have you ever observed, because it's not for everybody, but some persons, have you ever observed that, let's say I bring a bowl of water. If I have a bowl of water, and then maybe I put a rod inside that bowl of water. If I put a rod inside that bowl of water, and I observe from the surface, this is the eyeball of the observer. As I'm looking, it will be as if the rod is bent. Have you ever observed that thing before? Anybody? Yes. Good. If you have never observed it before, you are not a science student. You are probably an art student wearing science student clothes. or answering science students. Now, but there is a remedy for you. If you have never seen it, just go home today. When you go home today, bring a cup and fill it with water. If you fill that cup with water, put a spoon inside. If you put a spoon inside, as you are looking at the surface of the water, it will be as if that spoon is broken. And that thing shows refraction. It shows what, class? It shows refraction. So, Jambo Gajugi, that a metal rod is placed in a bucket full of water. The rod appears bent due to which of the following property? Full polarization, full interference, full reflection. And you now see refraction. What will be the answer now? Refraction. So it is due to refraction. Okay? Don't say that you have never observed it before. And because you've never observed it, you cannot answer it. Whether you have observed it or not, answer is refraction. Are you with me now? At this time, this critical time, even if you don't understand, you will cram it. Okay? That is why I have something called la cram la pour. There is la cram la pour la smash. Okay? So when you are in class and you are not understanding it, you la cram. When you go to the hall, you la pour. After exam, you la smash. Okay? So that is what we are doing now. Now, so that is that about the bending of objects. So there is nothing really much to say there. There is no analysis to do. There is nothing much to say there. The bending of an object. So that object can be a rod, it can be a stick, it can be anything. In fact, even you, Seth, it's in your way in memory now, and somebody is looking at you from the surface. It will be as if you are broken into two. It is due to refraction. Now, like when they were teaching us this thing, I remember one of our lecturers was talking about this while I was in school, my year 1. He was teaching us about refraction, and then he talked about bending of objects in a liquid or in water. And he told us a story that where he was living, that there was this woman, okay, that used to do all these catering services. You know caterers, right? So if you want to do a birthday party, you invite them, they will cook for you, or maybe burial and all that. Those people that used to cook for people. So this woman was cooking for a particular occasion. And then she told the girl that was living with her to put water on the fire. So the girl now poured water inside that big pot. You know that big pot that they use for party rice? That big pot. So, So she poured water inside and then now put that big spoon that they used to use to turn party rice. You know that spoon? What did they call it? Eku. Are you serious? What is it called? Eku. Okay, eku. Eh? What do they call it? I shake your head. What do they call it? Eh? Spoon. Ngaj. Normal spoon. Normal big spoon. Okay. Uncle, you gave us homework in the last class. Only your beloved bikono. You don't know, I don't care. So, as I was saying, so the gear now puts that big spoon now inside the pot. And you know, but because of the phenomenon of refraction, if you look at that spoon from the surface, it will be as if it is broken or bent. So the woman was now passing along. And she now mistakenly, I don't even know if it's by mistake or whatever, she now looked inside the pot. Obona the spoon, where they call baji, or where bought the girl. The girl are now abusable. Osia, why did you break my spoon? The girl was trying to because the girl was kind of surprised. Spoon, break, how? That kind of thing. Next thing, itawai. Just slaps the girl. The way you shouted now, that was how we shouted, hey, also. Because we were like, what happened? And then she didn't have nothing, she did not check. Okay, she just slapped the girl. And then started beating her up. People now came out and was asking, what is the problem? She was now saying, look at my expensive spoon. And this one happened that the girl has broken up a jigger. So our lecturer was now like, that he was hearing noise and decided to come out and know what was happening. And when he now came out, they now told him what happened. He now went close to see what happened. I like how the spoon, is it golden spoon that they broke, that they are beating somebody like this? And then as he now went close, he now saw that the spoon was bent. And to him, he already knew that refraction can happen. He brought out the spoon. And the spoon was still normal. Or do you see the woman? Where is the spoon that broke? The woman was like, on the phone. And they brought out the spoon. Okay? So just imagine, that innocent girl have collected beating because of what she does not know about. Now, when I heard that story, what do you know? One thing I generalized, that woman was an Itiaku. That is typical Iti. Because in fact, you don't even need to, in fact, okay, maybe a science student and all that. But you are supposed to know about the phenomenon of refraction. Okay? So if I was that lecturer, I would have lectured the lady about refraction that day. I would just tell her, biazie now. Biazie. I will carry stick and put inside that water. Is it looking like it's broken? She will say yes. I say okay. So here can about refraction. So your advantage is that biago lesson. Because if you had not say, you will not know. You will know. You will know. Who go this you now? You will know. You will know. You would have beat somebody to death. Okay. Now, that is that about this one. Now, let's talk about the fish eye view. Let's talk about the fish eye view. How many of you used to go to the village? Don't lie. You used to go to the village. Okay. Once in a while. When last did you go to the village? You went last year. Kendi Naga steadies, like steady. You used to go steady. Where's your village? Uji. Ndenkwo. Unangwogo. Anabacha, right? Now, those days, as kids, okay, I think the last time I went to the village was in 2021 or so. I can't remember. Okay? But as kids, we love going to the village. But once it's December like this, Mommy, are we going to the village? Like, we don't care how the situation of the economy is. We want to go to the village. Because there's always fun things to do. But now I can't go to the village again because I'm so popular. You understand? You have to go that kind of thing. I'm so popular. Okay? The last time I went to the village, I could not even come out. I could not come out because most of the lesson was village Mkashi. I couldn't go to the village. Okay? Because once I just step out and just reach field like this, Uncle Prime. Like, I just tire. So sometimes if I just go, I'll just stay inside the house. So, but as kids, we like going to the village because once we go to the village, stream is the next thing. Now, what happened? In my village, for those of you that don't know my village is in Oklahoma, USA. Okay? Now, listen, let me say the truth. I'm from Enugu here, okay? And then I'm from Ogu local government, okay? And then from Ogu, I'm from Isuawa, okay? So, now what happens is that in our village, the stream is called Iyakwezi, okay? And the stream runs through different places, okay? There is a part that is very, very clean. That the villagers used to even go and fetch the one they would drink for, and even drinking and cooking and all that. Then there are some that passes through like people's backyard and all that. Those ones, you can use it to do things like maybe take your bath, washing and all that, but maybe not cooking and all that. Okay? So that one passed through our backyard. So they not even used to tell us every day we used to go to that one. Now, when you enter that stream, when you enter inside, once you put your leg inside, you will see some fingerlings. That is small fishes. they will just be going around your leg, like swimming around. Like they'll just be swimming. And then what happened? As kids, we want to catch them. So that when we go home, we'll not train it. Yeah, we want to train the fish. So what happens? The truth is that we never caught anyone. So when the fish will even come very close to your leg and just be swimming around. So what we used to do those days is if you see anyone near your leg, you just do like this. Like put your hand to catch it. And then any sudden movement, it will move. It will go away. So you go down slowly. You'll be going down slowly to catch one. And then what happened? You see that even after going down, you will now dive the fish. The fish will now phew. You will not be able to catch anyone. Now, I thought we used to have bad luck until I read physics. Physics is the kwanebu. Physics is the egu, guys. In fact, after God, the next thing is physics. Physics, bio which lodge? Bio which lodge? So, when I read physics, I now understood why we were not able to catch any fish. Now, class, this is the stream. And this is the fingerling. Don't laugh at the fish, please. It's even fine, Seth. Laugh now if you want to laugh. Is it not fine? Now, look at the observer. Look at the observer. This is the observer eye. Let's just use the eye. Now, what happens? As the fish is in the water, now, water and the air, which one is denser, class? Jesus. Water and air, which one is denser? Water is much more denser than what? Air. So what happens? When the light rays from the fish eye is coming out of water, when it is coming out, it used to refract away from the normal. It used to do what, class? Refract away from the normal. I will still tell you this more when we talk about real and apparent depth. Now, it normally refracts away. Now, look at how it will look like now. So once it comes out, look at how the rays of light will look like. It will look like this. You see that all this region, the fish is able to see it. So fish can see all this region. Now, you see that compared to when the fish is in water, when it was in water, look at the only place it could see. Because look at the rays of light. Look, this is the area they cover. So this is where the fish can see when the light rays is still in water. But when the light rays emerges out to air, because it refracts away from the normal, all this region will be visible to the fish. So even if the fish is in front like this, and you, the observer, the catcher, is at the back like this, the fish does not have eye at its back, but because of refraction, it is seeing you. That is what it means. So the fish is facing forward. It will be looking like that. But your image, everything is in front of it. You are at the back like this, and you are saying, the fish is not looking at me. And then the fish on its own, he will be looking at you. As you are doing like this, coming, and I say, who is this idiot? Okay? And then when you now make any sudden movement, phew, it will run away. So the fish is able to see you, even if you are behind it, because of refraction. Because of getting now? Refraction. So that is what we mean by the fish eye view. Refraction enables the fish to have a bigger field of view in air. So it is because of refraction. So we have done the first one, which is the bending of objects in water or a liquid, and we have talked about the second one, which is fish eye view. Now, the next one we'll talk about, which is real and apparent depth. What is our time? Is it 12 already? What's the time? 11:58. People will just kill you. Okay, so what will happen is that in the next class, we will talk about real and apparent depth and also talk about what? Total internal reflection. Is that okay? I'ma see you when I see you. Yes, question? Question.